On this page, we'll talk about a kind of a new example. We'll talk more about categorical variables and the relationship between them. But in this case, the explanatory variable will be the same. We'll talk about females and males. How do they compare in this new setting? Not the body image issue, but a new question. But we'll compare them with a similar kind of example. Let's see. So the example is community college enrollment. The following table summarizes the full-time enrollment at a community college located in a West Coast city. Could be ours, I guess, huh? There are a total of 12,000 full-time students enrolled at this college. The two categorical variables here are gender and the program. So you're in the nursing program, the agriculture program, etc., etc. The programs include academic and vocational programs at the college. Assume that a student can enroll in only one program. So it's just these students have already chosen the one program they want. They're not enrolled in multiple ones, or they're not undecided. They've all decided what program they want to use. So you see that in this table down below, the very first row represents females, and then the second row represents males. So we got females in the first row, males in the second row, and then as the previous page pointed out, if you look at columns, it represents the first kind of box here represents females that are in the art science program, because on the left it matches up with females, above it matches up with art science. If you move over to the right, we're still in the female row, so we're talking about females here, but now we're in the program of business economics. And then the next, again, it's still females. All the numbers in this row represent females, but in the individual categories or the individual programs. So information technology, 494, we're in that program. Health sciences, 421 were in there. Graphic design, 105. Culinary arts, 83. And then we have the totals here. Total 6,000 and some change females. Males, art science looks pretty similar, huh? 4,334. A little bit less, but not too much. But then again, the totals are different, so I don't know if we can compare these raw numbers. But quite a few more males in the business economics program than the females, and quite a few more males in the information technology. But look at the health science, far fewer males than females, although, like we said, the totals are different, so it's kind of hard to compare. But kind of interesting, right? More or less here and there. And then the very final the final row is the totals. So just for art sciences, how many total people, female and male, put together. So basically these numbers on the bottom row here are just adding the numbers above them. So the let's see, try to use a different color, sorry. Here, yeah, let's clean that up because I've been writing on it so much. The 8,994 is just how many art sciences students are in that program. That's this number plus this number added together. And then the same thing here, 925 is the total number of people in the economics business program. That's the number of females plus the number of males, and on for all these. So now let's consider a few preliminary questions to get familiar with this new raw data. So it's hard to draw conclusions from this raw data until we think about some percentages, because like we said, the total number of females that are enrolled in this college is quite a bit more, not too bad, but a bit more than the number of males. What proportion of the total number of students are male students? Okay, so we're going to answer that by dividing the number of male students out of the total number of students, which gives us 48.35%. So it's about half, just a little less than half. And then let's answer the question, what proportion of the total number of students are business economics students? So that one we'd answer by dividing the number of business economics students out of the total number of students. Because notice that question didn't ask anything about males or females, it just said students total. So we're just taking, the total number of business economics people, that's 925 versus the total number of students that are enrolled in the college, 1,200. Looks like about 7.7%, which is not too huge, right? Okay, let's move down a little bit and look at more here. Note that to calculate this proportion, we use two numbers in the margin that relate to just one of the categorical variables program. This calculation is therefore called a marginal proportion. So that might be a good thing to write down, just in case. Now, marginal proportion, it means it's not related to the explanatory variable, I guess. No. Oh, yeah, related. Note, the proportion does not help us determine if gender is related to program because it involves only one of the variables, not the explanatory variable. or not related, I guess I should say in the definition that we wrote, not related to the explanatory variable or not related to categorical. So I guess it doesn't relate both explanatory and categorical. It's one of the marginal ones, like, let's see, if we move on over here, it's something that only involves these numbers, the raw totals, so females and males, but it has nothing to do with program. So that only involves the explanatory variable, not the categorical one. Or it's in this margin where it's talking about totals with the programs, not with the explanatory variable of gender. So I guess that's what the definition of marginal proportion is. It doesn't involve both categorical and explanatory variables at the same time, only one or the other. So okay, now let's consider the following question. If we choose one student at random from among all the 12,000 students at the college, how likely is it that this student will be in the business economics program? From our previous calculation, we know that only about 8%, but exactly 7.7%, or more precisely I should say, of the students at the college are in the business economics program. That's a fairly low number, so it's not very likely that our random student will be a business economics student. One way to state our conclusion is to say there is about an 8% chance of picking a business economics major. This means that if we selected 100 students at random, we would expect an average of 8 of them to be in the business economics program. Here's another way to state this conclusion. There is about an 8.08 probability of picking a business economics major. So we'll talk more about probability later in this class, but I guess probability, usually leave it as a fraction, sometimes depending on what you're talking about, or as a decimal. So this is what we had before we changed the decimal to a percentage. So that's how we like to do it in probability. Okay. Because this probability is exactly the same as the marginal proportion we calculated earlier, it's called marginal probability. And I think we'll see more of that in the future as we kind of go through this class more. It's customary to use the capital letter P to stand for probability. So instead of writing the probability that a student is in the business economics program equals 0.08, we write P parentheses student is in business economics equals. So that's more the math way to write it, right? Like an equation. And it's faster to write. I think, of course, math people like to not write, or they like to write as little as they can, which is why we're not so good at writing essays and stuff like that. Student is, yeah, business economics. So it's in parentheses. P represents probability. Whatever's in parentheses is what you're trying to calculate the probability of. Equals is, and then you want to write the decimal form of the percentage, or the proportion, I should say. So here's another example, conditional probability. Here is the community college enrollment data. So we have the column again, or sorry, the table again, just because it was kind of high up there. We want to come back to it. If we select a female student at random, what is the probability that she is in the health sciences program? So that's a good question. It has to be a female student. In this case, that's what they're asking. So we're only going to focus on this first row, because these are the numbers we're making sure we're selecting a female student. So all the numbers in the second and third rows, we're just not even looking at those. We're only considering the female information. So in that answer, of the 6,198 females, which we got from this raw total over here on the right, at the college, 421 are enrolled in health sciences. That was this number here. Find these numbers in the table. Yeah, okay, we did. The probability we are looking for is, so the part, sometimes we write that in probability. I can't remember if we've gone over that yet. Probability, we say it's the part you're interested in out of the whole or the total. And you divide those. And that'll give you the decimal part. So 421, that was the part we were looking for, the health sciences, out of the total number of females that we were polling here, or the total number of females enrolled in this college, 6,198. If you divide those numbers, you get 0.07, which is 7%. But with probability, we want to leave it as a decimal. But if we were talking about just statistics in general, we were just looking at statistical studies, we weren't talking about probability, we could write 7%. But yeah, like we said, probability, you want to keep it as a decimal. Therefore, the probability that a female student is in the health sciences program is approximately 0.07. Although that number doesn't really mean a whole lot to us as people, I mean, just random people. I'm thinking 0.07, what the heck does that mean? So in my mind, whenever I hear a number like that with probability, I always convert it to a percentage in my head so I can better understand it. It's just, technically, with probabilities, we're supposed to leave it in decimal form, even though it's harder to wrap your mind around than a percentage. Okay, now we'll focus on the language. We need to pause here and be very careful about the language we use in describing the situation. Note that we start with a female student and then ask what is the probability that this female student is in the health sciences department. That's why I said we were just going to focus on that top row. Don't even look at the row with males or the bottom totals. In this case, our starting point is that the student is female. This information sets the condition for calculating the probability. So definitely, the way a probability question is phrased really matters on how you're going to calculate it, what numbers you're going to use. Once the condition, in this case the student is female, is set, we focus on the female student population. In terms of the two-way table, it means that the only numbers we will be using are in the female row, 421 and 6,198. Okay. Now we talk about what is a conditional probability. So we use the word conditional up there. What's that really mean? This might be a good thing to write down. The probability we calculated earlier is an example of conditional probability. In general, a conditional probability is one that is based on a given condition. Here, the given condition is that the student is female. Here's the notation we use for conditional probability. Original question, if we select a female student at random, what is the probability that she is in the health sciences program? So the notation we'd use for that, if we were writing this in kind of the math notation with equations and symbols and stuff, P, parentheses, student is in the health sciences, given that, so we use that phrase, given that. That's something that's already been established. We're talking about only females here, so that'll affect our probability. We also write as P, health science. So this is kind of, like I said, with math, we like to write as little as possible. So we've even taken this P with, it's got parentheses with how many words in it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, that's way too many words for my taste. We even got it down to 4 words. Just, it's not grammatically correct, but you know, someone would understand what you're trying to ask here. The probability, health and science, given female. You know, if you saw that table, you'd kind of understand what was being asked, even though it's not grammatically correct. An even shorter way of writing this is to use a vertical bar. See how crazy math people are? Like, you know what, this isn't precise enough and it's not, I can't write it as quickly, so here. So that's a good thing to write down, because we'll talk more about percentages in the future, but if you ever see probability with a vertical bar inside, bam, like that, so there's some kind of phrase or words here, some kind of phrase or words here. This vertical bar, you can always read that as given that. So you're going to be calculating the probability of this happening given that this is already established. Almost looks like a face. Alright, now I'm confusing you, I'm sorry. I gotta got some eyes here. Okay.